Our final section in this chapter is to look very briefly at bicyclic molecules. Bicyclic compounds are when we have two fused rings together. And by fused rings, we mean something like this. We do not mean something like that. Bicyclic rings are important in a number of places. Examples can include molecules such as this one, camphor, which makes up about 15% of rosemary oil. And then we can have even more complicated. So we add a third ring is tricyclic. A fourth ring would be tetracyclic. And of course, we talked about this as a steroid earlier. So the main and really only piece I want to do right now with bicyclic compounds, although there's something we'll see again and again later on, is to just do some nomenclature. Because they are probably the one class of molecules that has a very, very different system of nomenclature. So, first step, count all carbons within the fused ring system. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means this would be some sort of decane. Second step, find the minimum number of bonds that need to be broken to form an acyclic molecule. So for example, if I broke that bond, I still have a cyclic molecule. But if then I also broke that bond, now I have an acyclic system. And so if it's 2, which is what it is here, we'd refer to that as bicyclo. If it was 3, we'd call it tricyclo, and so on. The final piece is we refer to the 2 carbons where the rings are fused together as the bridgehead carbons. And so step 3 is count the paths between the bridgehead carbons. So I have one path that goes this way, one that goes this way, and one that goes this way. How many carbons are in each path? This first one, 1, 2, 3, 4. This path has 1, 2, 3, 4, because we do not count the bridgehead carbons. And then in the middle, we have none. So we call this compound bicyclo 4,4,0 decane. So let's do one more. Which is this one. Here are our bridgehead carbons. If we break any two bonds here, we'll end up with an acyclic system. So we know this is bicyclo. We have a total of 7 carbons in our fused ring system. So this is heptane. And then I've already put our bridges into different colors. You can see if we go this way, we have a 2-carbon bridge. Over here is also a 2-carbon bridge. And going up this way is a 1-carbon bridge. So this compound is bicyclo 2,2,1 heptane. From here, you should get out in-class exercise number 15 and work through some of those problems.